Let's look at how to find the domain using a formula or equations. This is known as finding the domain algebraically. We'll look a little bit at the range, but primarily we're going to be interested in algebraically finding the domain. We're going to do this for four main classes of functions. So we have polynomials, like ax squared plus bx plus c. I have odd roots, where that number in the root is an odd, so the cube root, the fifth root. We have even roots, so that number on the root is an even number, so square root, fourth root, and so on. And then rational functions, and rational functions are really just fractions. Okay, so those are the four main classes we're going to look at. What I'd like you to do is look at numbers 13 through 16 and just identify which one of those four it is. There's one of each there. Okay, so let's see if we came to about the same place. Number 13, x cubed plus 4x squared minus 7x plus 8. That is definitely that ax squared plus bx flavor. So there's a polynomial. I have the fifth root of x plus 3. That 5 is odd, so this is an odd root. 1 over x plus 6. This looks like a fraction, so it's a rational function. And then number 16, the fourth root of x plus 5. So that 4 is even. That makes this an even root. All right, let's look at how to find the domain for each one of those classifications. So the polynomial, an example of that might be something like x squared minus 7x. And we could put any value of x in here and crunch that on our calculator and get an answer. So that domain for polynomials is all real numbers. So any value of x that's a real number. You can write that as an r with the two legs on the left side. You could also write that as an interval. So negative infinity to positive infinity, or as an inequality. So x is between negative infinity and positive infinity. So any of those three will work great. Odd roots. So an example of that is the fifth root of x minus 7. And the domain for all roots is also all real numbers. And let's look at maybe a little bit of why that's the case. So if we look at negative 1 cubed, that's the same as saying negative 1 times negative 1 times negative 1, which is equal to negative 1. And so if I can cube something and get a negative number out, I can take that cube root of a negative number and get a value back out. So I can put in negative numbers, positive numbers, or 0 into an odd root, and I will be good to go. Okay, so again, any of these representations for all real numbers is fine. Even roots are a little bit different here. So with even roots, we can't take, say, the square root of negative 5. So negative numbers are out, at least in the reals, right? If we were using imaginary numbers, we could get away with that, but not in the real numbers, and that's all we use in this class. I could take the square root of a positive number, so the square root of 16, for example. And I could also take the square root of 0. So positive things in 0 are acceptable to put under a square root or an even root. And so the way that we find this domain is we're looking for where g of x is greater than or equal to 0. So it's either 0 or positive. And so we'll solve g of x greater than or equal to 0 to get our domain. So in this example, I'll take that x minus 7, say it's greater than or equal to 0. I can add 7 to both sides, and I get x is greater than 7 for my domain. So any value of x is greater than or equal to 7. Right, and then rational functions. So the thing with fractions is that we can't divide by 0. So we want to avoid ending up with a 0 in the denominator here. The way that we'll do that is we'll say g of x cannot equal 0. So we can put any number in other than whatever makes that 0. And so to find the domain, we'll solve g of x not equal to 0. So I'll take x plus 15. I'll say not equal to 0. I'll subtract 15 from both sides. So that tells me that I can put any real number in except for x is equal to negative 15. That's the only number that's not in the domain. All right, so let's go back to these four that we already identified. now that you've seen how that works, let's go through these and then I'll have you try some in a minute. So this is a polynomial. We know that the domain of polynomials is all real numbers. So we're good to go there. The next one was an odd root. And odd roots were also all real numbers. So we're good to go there. So it's really nice if you identify what that function is. This does make this quite a bit easier. See, we said 15 was a rational function. And the thing with rational functions is we don't want the denominator to be equal to 0. So my denominator here is x plus 6. So I'm interested in solving x plus 6 not equal to 0. So that means x cannot be equal to -6, but anything else would be fair game. All right, and then we have this even root. And the thing with even roots is whatever's under here has to be greater than or equal to 0. That's what we have here. So I'll take x plus 5. I'll set it greater than or equal to 0. I can subtract 5 from both sides. And what I get is x is greater than or equal to -5. So that would be the domain for this function. All right, so we have 5 more functions left on the page here. Go ahead and pause the video and give those a try. I would start by identifying what type of function it is first and then go from there. Okay, so hopefully you tried those all out. Let's see, number 17, this is a rational function because it looks like a fraction. So I need the denominator to not be equal to 0. So in other words, x squared cannot equal 0, which means x is not equal to 0. And otherwise, I can plug any other number in that I want. Number 18, so this is an odd root. So odd roots, we are allowed to plug in any real number. So all I had to do was identify that as an odd root, and I'll put all real numbers. Number 19, I have x minus 3 quantity squared minus 2. This, I could FOIL this out. I could put those 3 copies of x minus 3, multiply through, and I'd have some sort of x cubed plus or minus a bunch of stuff. So this one is a polynomial. That makes its domain all real numbers. Right, number 20, so we're back to a fraction. This is a rational function again. So we need to solve for the denominator not equal to 0. So I have x squared minus 9 not equal to 0. So you could factor this. So it would look like x minus 3, x plus 3 cannot equal 0. And so that tells me x is either equal to -3 or +3. If you solve this by moving the 9 to the other side, that works also. Just be really thoughtful about this. So I have x squared minus 9 cannot equal 0. So x squared cannot equal 9. If I take the square root of both sides, you want to make sure to remember that square root comes out with a plus or minus 3 there. So either way, I'll get to the same place. All right, and then last one here. So square root of x squared plus 9, this is an even root. And what I need is for x squared plus 9 to be greater than or equal to 0, which means x squared has to be greater than or equal to -9. Can I take the square root of a negative number? I can't do that. So that means there is no way that x squared plus 9 is going to be equal to 0. Okay, so this is a false statement. There's nothing that'll make this work out. And so it turns out that in this instance, my domain is going to be all real numbers. If you aren't quite convinced, think about this. If I take x and square it, I'm either going to get 0 or a positive number, right? You can't get a negative number out of that. And then I'm going to add 9 to whatever I got from that x squared. So that thing will always be positive, which is one of the things we're looking for in an even root.